Okay, today we are going to discuss the four major types of drainage patterns. I trust you have already read that first, so you recall that the drainage pattern is the arrangement of channels that carry water in an area. Now, these patterns can be very distinct since they are determined by the climate, the topography, and the composition of the rocks that underlie the formations. So, consequently, we can see that the drainage pattern is really a good visual summary of the characteristics of a particular region, both geologically and climatically. In other words, when we look at the drainage patterns, we can draw conclusions about the structural formation and relief of the land as well as the climate. Now, all drainage systems are composed of an interconnected network of the stream, and when we visit to do, they form distinct patterns. Although there are at least 7 identifiable kinds of drainage patterns, for purpose we're going to limit the four major types. Probably the most familiar pattern is the dendritic drainage pattern. This is a stream looks like the branches of a tree. Here's an example of a dendritic pattern. As you can see, it's similar to many systems in nature, in addition to the structure. This is a very efficient drainage system because the overall length of any branch is very short, and there are many branches, so that allows the water to flow quickly and efficiently from the source or sources. Okay, let's look at the next example. This drainage pattern is referred to as a radial pattern. Notice how the stream flows from a central point. This is usually a high mountain or volcano. It kind of looks like a spoke that laid out on the harbor wheel. When we see a radial pattern, we know that the area has experienced uplift and that the direction of the drain downslope are relatively isolated central point. Going back to the dendritic for a moment, the pattern is determined by the direction of the slope of the land, but the streams flow in more or less the same direction, and so it's unlike the radial that had multiple directions flowing from highest point. Now this pattern is very different from either the dendritic or the radial. This is rectangular pattern. We can change just look at those right angle turns. The rectangle pattern is difficult landscape can hold by fractured joints and folds. And because of this rock is eroded and broken rock, stream beds are curved along with the jointed bedrock. Finally, you have the trellis pattern. Here in this example, you can see quite clearly how the tributary of almost parallel structure drain into variants. The forms appearances of regarding trellis. This pattern forms in areas where there are alternating bands of variable resistance. And by that, I mean that the bands of rock that are very strong and resistant to erosion alternate with bands of rock that we erode when horizontal plane fold and outgraphing appear. So, as I said, as a whole, these patterns are dictated by the structure and relief of the land. The kind of rocks in which the streams develop the structural pattern with the folds, and the average will usually determine drainage system. Well, I should also mention that drainage patterns can occasionally appear to be out of sync with the landscape. And this can when the stream flows over older structures that have been uncovered by erosion or when a stream keeps its original drainage system when rocks are uplifted. So when it happens, the pattern appears to be contrary to the expected courses. But I expect you to know that the exception to the pattern can occur when zero discrepancy informs them.